Hi, welcome to the beginning of Chapter 10. We're going to spend a couple days on this section. The idea of Chapter 10 is rather than trying to solve systems using substitution or elimination, we're going to use matrices as a method of helping to organize our information. You can do all of these problems on a calculator. We're going to be doing them by hand. Reason being is I am prepping your mental math skills for something that is coming next semester in chapter 6. I trust your mental math skills. I know you have mental math skills, but unfortunately they're not quite riding a bike. You can't just hop back on. So we need something to warm ourselves up to that idea, and that's our plan for chapter 10. And that's why we do these matrices by hand. Today, however, will be just a general introduction. Now, the reason that we do these matrices instead of just solving by substitution or elimination, it gets really gross. You have to take two of the equations, one pair of them, do elimination with one of them, and then choose a different pair of them and do elimination again, and then you get a new system of equations. Then you do substitution or elimination, and it's just like, ugh, because then you have to climb your way back out of that hole, and it's just yuck. No. So we use matrices to do this same thing, but in a way that is a little more organized, a little bit more straightforward. Now, any matrix is made up of an array of elements. So you've got, this is the thing in row 1, column 1. This is what is in row 2, column 2. This is in what's in row 1, column 2. I think I said this wrong, row 2, column 1. The up and down number, that is the first number, is the number of columns. I think this is backwards. So this is a row and this is a column. So this is actually backwards. Oh my gosh, I just noticed this. Yeah. So a row, no, yeah, row goes left and right. These are all of our rows. So that is a row that we've got our first row, second row, third row. And then the columns go this way. It's not counting. Sorry. So a square matrix is ones where the numbers are the same, 2 by 2, 3 by 3, 4 by 4, but they don't necessarily have to be in that orientation. We can have a mismatched number of rows and columns. And elements are all these little spots in here. Don't worry too much about making this diagram perfectly. It's just meant to be it can be big or it can be small. So if we have a matrix, if it's n by m, we want to try to determine what its order is. The first number is the number of rows that are in the matrix, and the second number is the number of up and down columns. So if I looked at this first matrix here, I want to make sure my thing doesn't crash. If I looked at that first matrix, it's got 2 rows, and it has 2 columns. So it is a 2 by 2 matrix. The second one over here has just 1 row. And it has 1, 2, 3, 4 columns. So that is a 1 by 4 matrix. This matrix down here has 1, 2, 3 rows, but only has 1 column. So it is a 3 by 1 matrix. This matrix here is 1, 2, 3 rows, and then 1, 2, 3, 4 columns. So it's a 3 by 4 matrix. Easy as that. It's I personally struggle with keeping straight which one's rows, which one's columns. I always have to check before I start this unit. So there's 2 ways of creating a matrix to help us solve this these systems. And we're going to do it with a 2 by 2 just to kind of make things a little bit easier. But mostly matrices are used for 3 by 3 systems. We will talk about 2 by 2s just so that it's a little bit easier so we kind of understand the methodology. Because if we just did 3 by 3s, they take a while. Now, when you did this in advanced algebra, most likely you created a matrix equation. When you're working with them there. This is the common way that they're written. It's a collection of separate matrices. So you grab all the coefficients, 3, 4, 1, and -2, and they have their own little matrix. And then you grab the variables that you have. So there's an X and then a Y, but it's in like a kind of a 2 by 1 matrix. And then on the other side of the equation, because then you have that little equal sign, you've got the two numbers that it equals. Now, mathematicians were trying to solve these things, and it's really they were just trying to get the X and Y variables by themselves. And mathematicians are very lazy people. And if there's a way that we could kind of like simplify and say, well, do we really need all of this if we want to work with this matrix? And they realize, no, we actually don't need all of this because that X and the Y just kind of sits there. It doesn't do very much. It's the outside numbers that do all the work. So let's just get rid of it. And they found out they could. And what they created, what is called an augmented matrix. They use that same idea of grabbing the coefficients, so 3, 4, 1, and -2. But then they knew it's just like, okay, well, there's the variables and the equal sign, and there's a whole bunch of a hubble that really doesn't do anything. So they just made a big line. That's the augmentation line. And that acts as our variables and it acts as our equal sign. And then they brought the 1, 7 in there. So it's not a square matrix anymore, but it is a 2 by 3 matrix. And we can work with this one rather than the collection of matrices in the matrix equation. And this is the land that we're going to be working in. We're going to be playing mostly with these augmented matrix. I'll bring the matrix equation back at the very, very end of this unit, like very, very end of it. But we're not really going to work with it too much. If you'd like to on your calculator, by all means, then you can do augmented matrices on your calculator as well. But I'm just going to be mostly working. Now, the most important thing that we're going to be doing this chapter, and this is the main thing I really harp on for people to know how to do, this is that mental math gymnastics that we're going to be working on, is these row operations.